Okay, now we continue with integration of inverse hyperbolic function. We look at example 5 in page 55 from previous semester papers, October 2012. Okay. The question is, evaluate integration of sec 5x tan 5x over 25 minus sec squared 5x dx. The solution is as follows. Okay, from the given question, we have numerator sec 5x tan 5x. And in denominator, inside squared, we have sec 5x. The relationship between sec 5x and sec 5x tan x is when we differentiate sec 5x, we should have term containing sec 5x tan 5x. So means that we can choose u equals to sec x, sec 5x. It is because when we differentiate sec 5x, it becomes negative 5 sec 5x tan 5x. So means that when we differentiate sec 5x, we have term containing sec 5x tan 5x. That is the function in numerator. Okay, means that we can simplify it. Okay. Okay, so after we identify the suitable u, we can write into the form of a squared and u squared. Okay, because just now we choose u equals to sec 5x. So we can write u squared here. So if we write u squared, so we can write constant squared here. Okay, that's why we write into the form of a squared and u squared. Okay. Okay, so from denominator, we write 25 equals to 5 squared, and sec squared 5x, we write into the form of sec 5x bracket squared. Okay, and after that, we can use u substitution. A should be constant. Okay, so now our A is 5, and we choose u equals to sec 5x. Because when we differentiate, du over dx is negative 5 sec 5x tan 5x, and this function appear in numerator. Okay, so the following step, we can simplify this. Okay, after we differentiate, we write dx as the subject. So we have du over negative 5 sec 5x tan 5x. And after that, we substitute back. So now we have integration of, we still write the numerator sec 5x tan 5x. And then we replace 5 by a. And then in between is minus. And we replace sec 5x by u. So we have u squared here. Times dx. Okay, dx equals to du over negative 5 sec 5x tan 5x. Okay. The step is we replace 5 by a from here. Okay. We replace sec 5x equals to u from here. And we replace dx equals to du over negative 5 sec 5x tan 5x from here. Okay. We no need to replace sec 5x here in terms of u because we want to simplify with the denominator here. Okay. Okay, after that, we simplify sec 5x tan 5x from numerator and sec 5x tan 5x from denominator. And then we can move out constant negative 1 over 5. Okay, 1 over 5 because negative 5 here from denominator. So when we move out, it should be negative 1 over 5. Okay, and then inside integration sign, we have 1 over a squared minus u squared du. Okay. Okay, after that, from here, we can refer from appendix. Okay. And it's similar to appendix number 19. Okay, we have integration of 1 over a squared minus x squared with no square root. Okay, this one no square root. That's why we compare with formula number 19. Okay. Okay. And after that, if we compare, so we have integration of 1 over a squared minus x squared here equals to, either we can write in terms of ln or we can write in terms of inverse tang because a comes first. So from modulus x less than a, okay, means that a comes first. Okay, from here. So we can write inverse tang. In the previous video, we write this formula in terms of ln. So now, we can try to write in terms of inverse tang. Okay. So, we can write negative 1 over 5 and then 1 over a inverse tang u over a plus c. From here, 1 over a inverse tang x over a plus c. Okay. Okay, after that, after we write this formula in terms of tang, okay, finally, we replace a by 5 and we replace u by sec 5x and a by 5. Okay, so after we simplify, we have 5 times a is 5, so we have 25 here, and then u is sec 5x and a is 5. Okay, so the final answer is negative 1 over 25 inverse tang sec 5x over 5 plus c. Okay, you got it? Okay, now we continue with example 6, page 56 in chapter 2 from your handout. Evaluate integration of 1 over square root of 4 plus 2 bracket x minus 1 squared dx. The solution is as follows. Okay, from the given question, the numerator is a constant. And the function inside cert symbol in denominator is quadratic if we expand. Okay, means that after we integrate, so the answer may be we get inverse trigo or maybe we get inverse hyperbolic function. Okay, so if we guess that the answer should be inverse trigo or inverse hyperbolic function, means that we can refer from formula in appendix. Okay, from this formula, okay, that we get from appendix, okay, coefficient of x should be 1. Okay, okay, so means that what should we do is we need to move to the constant 2 from cert symbol, okay, to write into the form of a squared and u squared. Actually, we can expand 2 inside bracket, okay, but you need to be careful because we need to expand squared first, okay. So the best way is we need to move out constant 2 from cert symbol, okay, but how? Okay, firstly, we need to factorize 2. Okay, we factorize 2, so in bracket we have 2 here because when we multiply 2 times 2, we get back 4 here. Okay, and when we expand 2 times bracket squared, we get back 2 times bracket squared. Okay, and still inside cert symbol or square root symbol. And after that, we can move out constant 2 here. And 2 here is inside cert symbol and in denominator. So, if we move out constant 2 here, actually, we need to move out 1 over cert 2. Why 1 over? Because 2 here or cert 2 here comes from denominator. Okay, Why Z2? Because 2 here inside Z symbol. So when we move out, it should be 1 over Z2. And this is constant because no variable x here. So that's why we can move out from integration sign. Remember, never move out variable from integration sign. We only can move out constant from integration sign. So after we move out constant, so inside the symbol now, we have 2 plus bracket x minus 1 squared. Okay? And after this, we can write into the form of a squared and u squared. Okay? How to write the whole number into squared? Okay? The number that cannot be write into the form of perfect square. So we can write 2, okay, in terms of Z2 bracket square. Okay, because when we simplify, we can simplify square here and Z here. So we get back 2. Okay? And then we still have plus bracket x minus 1 squared. Okay? And after this, we can use U substitution. Our A is Z2. Okay, Z2 is constant. So the constant should be A. And then our U is x minus 1. And after that, we need to differentiate. So when we differentiate, we have du over x. And we differentiate x minus 1 equals to 1. We differentiate x, 1 minus 0. No need to write minus 0. So we just write 1 here. Okay. And then we write dx as a subject. So we have dx equals to du. Okay. And after that, we rewrite the question in terms of a, u, and du. Okay. So from here, we still have constant 1 over Z2 outside integration sign. Okay. And then we write Z2 equals to A. Because from here, we have A equals to Z2. Okay. And then we write x minus 1 equals to u. Because from here, we have u equals to x minus 1. And we write dx equals to du. Because from here, we have dx equals to du. Okay, and after that, we can compare with formula in appendix. Okay, we have 1 over Z2 integration of 1 over Z a squared plus u squared du. Okay, look at the red font. Okay, so when we compare with the formula in appendix, okay, it should be similar to formula number 17. Okay, because we have in denominator we have square root and then a comes first and then in between is plus and then x squared. But now our x is u. And the answer is inverse sinh. Okay, x over a plus c. So when we refer from this formula, okay, integration of 1 over square root of a squared plus x squared dx equals to inverse sinh x over a plus c, we can write, okay, 1 over Z2 integration of 1 over Z a squared plus u squared du equals to 1 over Z2 inverse sinh u over a plus c. Okay, because now our x is u. So we can write u over a. Okay. Here, okay, we replace this function or this integration into the form of inverse sinh. Okay, after that, we replace u equals to x minus 1 and a equals to Z2. So our final answer is 1 over Z2 inverse sinh x minus 1 over Z2 plus c. Okay, you got it? Up to this point, we have finished discussing Chapter 2, and this is the last video of Chapter 2, which is hyperbolic and inverse hyperbolic functions. Coming up next, Chapter 3, Integration Techniques. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.